All right, today I'm going to do a little cast iron repair on this brake shoe. Now this is a pretty interesting piece. This is a cast iron brake shoe off of an antique bandsaw that a friend of mine is restoring. This bandsaw was built in the 1940s. It's traveled around the country in a couple big facilities, cutting everything from airplane wings way back around wartime to producing mandolins, from what I understand. And it's landed in his shop and he's doing a full restoration. The little mounting point here for the pin broke off. And so we're going to reattach that today, and I'm going to TIG weld it. Now there is another repair that I can see sometime in its 80-year life. It has been repaired over here. It looks like this was stick welded, probably with a nickel rod, and you can see the little marks from peening it. And that's a good way to repair over there. And honestly, I think stick welding is a better process than TIG for this in general, except I'm dealing with some pretty interesting geometry where I want to be really precise. And I think that's more important than the help that I get in the flux in this situation.
Because I don't have much information about this part, I just want to verify that it's cast iron. This is a spark test, and you can see the sparks off the grinder. There aren't very many. They get bright a little ways away from the wheel, and they're kind of a red color. That's typical of cast iron, so I believe that's what we have. If it were cast steel, it would look something more like this mild steel with a lot more sparks coming right off of the grinding wheel and a little bit more yellow color. So I'm going to build a little fixture to hold this in place, and also to help control the temperature, because I'm going to preheat this and those small parts wouldn't be able to hold the preheat very well by themselves. So I'm using this scrap piece of aluminum. I'm going to cut it to length and drill a hole to fasten everything together. So here on the Evolution saw, I've got it down to length and it's a little bit too thick, so I'm going to take a little off the top here on my milling machine. A nice trick for setting this and taking some thickness is just to zero the caliper at the thickness that I want, and then measure the thickness that I have, and that's going to give me the difference without any math. It's right around 18 thou, and since this is a welding channel, I'm going to machine it like a savage in one single pass. And it's coming off clean. That's not all that much material to remove, so there shouldn't be any issue with that. Let's see how it fits. Looks like it's going to work out really well. Now I just need to drill the hole to be able to fasten everything together. And this is a transfer punch, and it'll fit down inside the existing hole. And I'll punch a little center point right there to be able to drill through on the aluminum. And this is going to give me a good base to be able to locate that when I grind everything out and help control the temperature. So sometimes putting together a little fixture could be just as simple as that. I know this uses some machine tools, but even without them, you can find different ways to fixture things together. That can save a lot of time, especially when you're preheating, because, you know, fitting parts together that are preheated, if you ever try to do that, it's just kind of a nightmare. So now I'm beveling everything out to be able to fill this in with weld so that I can get something good and solid. I used a grinder and a carbide burr. If I were to braze this, I'd want to use the carbide burr on every surface so I don't have any smeared graphite. But since I'm going to weld it, it will be fine whether it's ground with an abrasive or done with a carbide burr. I'm just using a regular fastener to put this in place, but I want that cylindrical shank up top to help line up those extra pieces, and it fit together really well, and I have a nice groove. I should be able to fill everything in from one side. I have a pretty wide range for preheat, 350 to 500 degrees, so the gas grill is going to work just fine.
All right, while that's heating up, let's just talk for a minute about filler metals for cast iron. There are a whole ton of them out there. The most common for welding are high nickel fillers. There's nickel 55 and nickel 99, which nickel 99 is the, nearly pure nickel. Nickel 55 has more iron in it, and I'm going to be using nickel 55. Now, across the board, nickel 55 is pretty much better. It costs less, it contracts more, which helps with cracking. It can deal with some more impurities than nickel 99. However, it's hard to machine. So if I have to drill that hole out, I might need to work on it with a file or something like that rather than just being able to machine it out. But I think it's worth it to use the nickel 55 for me today. Plus I have some here. Another option would be to braze it. For that, I'd probably use aluminum bronze rather than silicon bronze, just because aluminum bronze is a little bit higher strength.
I'm gonna go ahead and set up my machine and everything else so it's ready to go when I bring those parts in. And I'm welding with the TIG 251 today. This has been just an awesome machine. This isn't a sponsored video, nor are most of them where I talk about this. It's just really good equipment. This is my torch setup, just a number 10 cup, which allows me to extend my tungsten a little bit further out. Well, it's go time. So as soon as I get this off the grill, the clock starts to start welding on it. See, once I'm starting to weld, I add some heat in so it won't cool off quite as quickly, but I want to get to that point as soon as possible. You could use some insulating fixturing, like some fire bricks or things like that, but I think I'll just go quickly enough that it's not really going to matter. So the name of the game here is to avoid dilution with the base metal, which means I want a lot of filler metal in my weld puddle and not a lot of base metal. And so I'm just using a lay wire technique right here in the root pass, and then I'll come in immediately after and start peening with my chipping hammer. And that peening action is going to put some compressive stress into it and help avoid cracking as this cools down. And I'll run another pass over this and then continue that process, adding some filler in another pass and then peening and working my way up here. I don't want to have too big of a pass at once because it'll be pretty hard to control how much base metal I actually end up with. Here I'm pumping the pedal a little bit and dabbing. This allows me to control my dilution a little bit too by just reducing my amperage in between dabs and then adding some amperage when I'm actually dabbing the filler metal. And the welds are laying in surprisingly well. I'm not hearing any clinks or things like that that would indicate cracking. And visually, I don't see much. This is going to be loaded in compression the way that it's designed. So hopefully this holds up for a long time. I'm feeling pretty confident in it. So I just built up that little gusset there on the outside edge in basically a really short, large fillet. And now I'm adding in some nice tacks, pushing as much filler as I can here for that little section at the end of the tab. So once these are in, I can remove that fastener, but I'm going to leave the aluminum block in there to act as backing so that I can continue to maintain that temperature as evenly as possible, because that's the name of the game with cast iron, right? You don't want to shock it any more than you have to. So once those are welded out, I removed that block just to do a little tiny back weld on one side that didn't quite push all the way through. Now, it's probably overkill, but I also put a little fillet weld down inside the groove. That's a challenging weld to do, but I got something in there that I think will add a little bit more support. So after it's done, I'm putting it back on the grill just to allow it to cool slowly and the temperature to normalize, and it's right around 340 degrees, which is pretty good. So I'll take this opportunity to clean up. A lot of people ask, how do you keep your workspace so clean? Well, I just take a few minutes to clean up after each project, and then after 10-15 minutes, I'll turn off that grill and let it cool naturally. And this is the as welded result. The contours and shapes right there, that's what I was really going for, and that came out really nice, I think, for a cast iron repair. I do have some extra face reinforcement there because I was trying to push as much filler as I can and get a nice sound weld on it. And so I'll just clean this up a bit on the belt grinder and match drill this hole. Now I'm using an end mill here to match drill the hole because I'm just removing material on the edges or maybe on one side, and a drill bit could deflect a little bit where this won't deflect nearly as much, so it's working pretty well. And this is the finished result. I'm really happy with it. I think it turned out pretty nice for a cast iron repair.
Hey, thanks a ton for tuning in. I always appreciate it. If you are just starting out with welding or you want to learn and you want to learn faster than you are by watching videos, my online courses walk you through a step-by-step plan where you take action, and that's really where you learn. So check those out, linked in the description below. I keep them as affordable as possible, and I'll give you your money back if you don't find them helpful. Thanks a ton for tuning in. We'll see you next time.